And now to make cutouts for our windows and doors, I downloaded this picture. You can see the rough idea what we want to do is basically two stud boards together, and the kind of like squares for our cutouts for in our walls. So this is the idea what I'm going to do inside here. So let's do this. So let's take this from these studs. What you can do is put down a line node, and you want to make the line the same length as these studs, basically the same position. You can do this by adding a spare input on this line node from our completed stud. So I'm going to use one of my tools as add spare input, and if you don't use it, just go ahead and from this gear icon add spare input and just reference these stud nodes. But I'm going to use this method. So right now, and what our spare input actually gives us, it gives us ability to easily reference the geometry of this node. So first of all, I want to offset. So there's a couple of options for this line. First of all, we want to offset origin on our line node. Let's go to the right like that, because our stud boards are offset also, and our offset is based on the thickness of our stud boards. So we just want to a relative copy of our thickness of our stud boards, and in here we want to origin on the y-axis based inside like that. So now our line is offset, and for the height of it, which is the length inside this SOP, you want to get the bounding box y size of this geometry. That's why I actually created this spare input. So for the length of it, I'm going to use one of my tools. I'm going to get the bounding box y size, and it's going to be -1 like that. You can see we are now referencing this, and it should exactly match the line like that. So if you're not using my tool, just go ahead and create this expression. And now let's create a box. And this box is going to be our cutout shape for our window. So I'm going to make sure that everything that I do is actually on the z-axis. So what makes sure that z-axis of this box is actually the width of the width of our stud board. So I'm just going to copy this and paste inside the z-axis like that. This is because of our stud width is basically we want to be the same width of it. That's why we're making this box on the z-axis, because the z-axis actually is the axis that is going to be copied to. So we want to make sure that our walls is aligned with the z-axis like that. So that's good. And for this line, what we want to do is actually make two more lines at the beginning, basically at the sides of this box that is going to control the window size. So what we can do is actually go ahead and put down poly expand 2D. And what's cool about this poly expand is that there's actually an option for us to split offset curves to mid and caps. Turn this on, you can see, and if we change the offsets, you can see there's now two polylines at the sides of it. And by default, actually, it already should be aligned on the z-axis like that. And what we do is do the offset, and the offset should be the size of it on the x-axis. So copy the x-axis of this of box size and paste inside the offset like that, and divide it by 2. So this should make sure that our box, whatever the size of it, our lines are actually going to always follow it like that. And let's start adding some of these parameters to our HDA. So let's call this window control. So Windows controls. So what I want to do is start looking at some of these boxes. So I want to, let's copy the width of it. Actually, let's copy the size inside here. Applied. and this sadly deleted our width. Actually didn't. Oh, that's nice. I thought it would actually overwrite our parameter, but it actually didn't. So in this size, what to do, instead of vector 2, we can external vector 3, we can do it vector 2, because we want to control only the x and y axis, like that. So let's call this as, actually the size is fine. So this is going to control the size of it. And we also want to control the offset of our window, which is going to be our center, like that. So just drag this inside our HDA, and let's call this offset, like that. So now in our HDA, we can control the size of our window and the offset. So if we want our window to be higher or lower, like that. Now that we have our control of the box, what we're going to do is make sure that these polylines are actually keeping in size of our line. Basically, we have to rescale back these polylines, because even though we use this offset that is used by how big our box is, like that, you can see that these polylines are actually expanding and getting bigger. So what you want to do is actually offset them back to their back to the scale of these ones. For that, we can actually go ahead and use the same vex code that we use inside here. So just copy wrangle this, where we split our two polylines for the offset. Just copy them, paste inside here, and connect it up. Delete this reference, and we just want to copy the x reference of our window size and paste inside here, and divide it by 2, and also want to make sure that it's negative offset, like that. So we want to shrink this, and if we have done it correctly, our curve should be basically the same size as our line that we initially created, and after the poly expand, it should go back to the same height, like that. So this is exactly what we want. So this is good. And if I go template it, go to our box, let's say I want to make it bigger, you can see it's perfectly going to align, like that. So that's good. So now let's start on actually sweeping this geometry. So if we put down the sweep node, you can see that let's make sure that it's at the ribbon, and let's expand it, let's column to 0. You can see it works nicely, but there is a problem. So let's say we want to extrude. You can see that this extrude is going to follow one direction, basically the normal direction, even though I don't think even we have normals. But even without the explicit normals on the points, it's going to extrude it on to the positive x-axis. But basically the sweep is going to be like this. But we actually do not want to do, because we want to make sure that this box, anything we basically any size of this box, actually basically we do not interfere with inside the box with, because let's say you want to give our custom window, and want to make sure that this maybe this box is a representation, a good representation of your custom window that is created. So we want to make sure that any framing that we actually create is actually around the box and not inside it. So anything happens around our box. So this is why we actually want to give our polylines custom normals. So put down a point. Oh, the point expression is very nice, because it gives us some presets what we want to actually basically modify, and just put in on normals. And just like in wrangles, you can put in a set, and you want to set the normals to the positive x-axis. So 0, actually the 1, 0, and 0, like that. If you take a look at them, you can see our normals are now facing the positive x-axis. You sweep them, and you go to the poly extrude, you can see our poly extrude actually now is going facing opposite sides. So this is exactly what you want. Let's make sure to also output the back of these polygons, and let's actually make references to our stud boards. So this is going to control our width of it. So just copy the parameter of the width, and then we want also the thickness. Copy this inside here, like that. So now we have our copies like that. Now what we want to do is let's template our box like that. So from the reference, we want to get basically our top and bottom of our window is going to have another basically a board. We want to extrude basically. Let's go inside here. Let's output the back of this extrude node. I'm gonna call it inner board extrude, and let's blast. So let's blast this new group that we just created like that, and want to extrude it. So you want to extrude it inwards, and you want to also copy the thickness of the board like that. So these should be the same thickness like that, and also output back like that. And now what we'll do is actually boolean this box. So move this box inside here, put down a boolean, connect this like that. You can see now we are creating something of this reference image like that. So let me maybe put this, because this is a new type of operation we are doing here. So let's move it over here. Let's watch this together. You can see if I change my window size, you can see boolean is working really nicely. Now what we're going to do is create groups for our box. So put down a group node. In this group, let's call this top. Let's call it window top. Key by normal, and the top is going to be by up vector. Basically, what to do is get the top and the bottom of our window, because we're going to actually extrude those parts. So select top, which is going to be normal is going to be +1, and bottom is going to be -1, just like we did with our setup box like that. So we have our setup. So this is good. Now let's actually start by offsetting these newly created booleans, because I'm going to basically what I'm going to do is blast these two. So I'm going to show what we're actually going to do. Let's blast both of these groups like that, and want to extrude like that. And for our extrude not to interfere, let me merge these together like that in template. So you can see this is our base, and want to extrude these for our supports on sides of the windows. But you can see right now they are actually intersecting. So what we're going to do is actually take this boolean, get only these primitives, and actually offset them by their normal with the wrangle. So go to the boolean and output the primitive group. I think it was the B inside A group. So if you take a look at the groups and go to the B inside A, it's going to be this green group. Let's call it maybe something like that. It's basically going to be only these caps that are newly created. And what you can do is actually create a wrangle. So put on wrangle node, and want to offset them. Now let's run only through the B inside A group on this boolean. Actually, we can check if this group is correct by putting something like a transform, and select the group B inside A, and if you start to move it, so you can see only the boolean faces are actually moving. So this is correct group. So inside this, we want to make sure that we are running over the primitives. And let's open this up inside wrangle, inside code. So first of all, we want to get since we are running over the primitives, the point, we want to get all the primitive points, because we can't move a primitive. We actually have to move points in this primitive. So let's get all the primitive points first. Let's call it int prim PDs. It's going to be an array, prim points, geometry 0, and add prim none, like that. And now I want to get the normal of our primitive. So we should, I don't think actually we have to put down normal node. Make sure that we have normal set up, because I don't think the Rex code is actually going to pick them up if they are not set up. So let's call vector prim normal. Let's normalize them. V at n, like that. And now I want to for each int pt. Basically, want to run through each prim pts and basically offset them. So let's go get the. So now we are running through every point, every primitive point. Let's get that point position. pt position. It's going to be point geometry. Attribute name is going to be, and pt is going to be pt num. So, and in this diagram, you also notice that the upper part is actually thicker than the bottom one. So what I'm going to do is actually sort it by the normal of that primitive. If the normal is facing down, we're going to extrude it twice as much as the normal that is than the normal that is actually facing upwards. So we can do this by if v at n dot y, let's say, equals, let's start by 1. So basically if it's facing upwards, want to just make it thick as our baseboard is, the base stud board is. So let's do this. Set point attrib position. Point number is going to be pt. The value is pt position. Then we want to subtract, because we're going to subtract it, because we want to subtract this value, equals, then go to prim normal, prim normal multiplied by ch. Actually, we have to create also the offset float, offset like that, and just multiply it by offset like that. So that's good. Now we can just copy it and make sure that if the normal is -1, we want to update our primitive normal multiplied by, and let's put this in parentheses, offset multiplied by 2. Basically now our bottom is going to be positioned out twice as far as our top is going to be positioned twice as far as our bottom. So let's take a look at it. Let's create this offset. You can see I start to move it. You can see you can visually see that our top is moving more than our bottom. And all we want to do is take our relative reference of our thickness, copy it, and paste inside here like that. So that's good. And now I want to now that we have set up this code, what I want to do is go inside this blast node. And here we've extruded. Since we want to extrude actually by 2 different parts, 2 different values, we want to get 2 blasts, and in one of them we want to blast bottom and top at the other side, and I want also 2 different extrudes. So inside here, at the bottom we want to extrude it by the thickness, and inside here we want to extrude by thickness multiplied by 2, like that. And if we start to put all these together, so let's start by here and all of these together, we should have something like this, and let's also bevel them so that you can easily see the setup. You can see we are getting also remember to in poly extrudes also output backs, because by default they are not turned on. So let's start looking at it. We are getting something close to this, setup. So I'm not going to worry about these parts in the middle. Yeah, because in some of these drawings they are not there, so I'm just not going to bother it. But for now, this is good enough for us to create this. If you, let's say, change the size of it like that, it should really nicely work for us too as our window cutout. For our door framing, let's go ahead and copy this network, and we are just going to modify it a little bit. So first of all, let's delete this bottom frame group, because we are not going to extrude the bottom of it. So like that, and make sure that you also have to delete this. So now let's go ahead and open up our type properties and create new controls for our window, for our door control. So I'm just going to duplicate these Windows controls, and we are not going to use the offset of it, because the offset is now basically because our doors can be in the middle of the walls, so we do not need offset. I'm just going to need the size of it, and let's call it this collapsible door control. And now let's actually use these values. So by default, Houdini is just going to add a new integer to the if the parameter name already exists. So now we have to replace it with size 2. So go ahead to our box, and so size 2x and size 2y, like that. And now we can control the size of our doors, but I also want to make sure that our doors are always on top of our grid line, on our reference line. So just put down a match size, connect it, and connect the line inside here as a second input, and make sure that the justify y is at minimum on min and same, like that. And if you take a look at the result, there is one more problem. We have these ends. That's because of our well, basically our point where we are offsetting them back, it's still referencing our windows. So we want to make sure that it's size 2x, reference our windows x size, our door x size, and they should be done for our doors. Let's go to our parameters, let's change the size of them, like that, and this should be the size for our doors to be inserted. And with a little bit power, and with the power of foresight, let's actually change our line spare parameters, spare inputs. So I took a color as my spare input, where I took my y size. Let's actually get it from our top of our setup, which is our groups. So right after group setup, just copy this group 3 and name of this. Go to the setup and paste inside, instead of color 4, group 3 and group 3. So this is going to help us to make sure that we do not get infinite recursion when we are actually referencing size of our windows and doors. So I'm going to show you why we did it. So just make sure that you are referencing it before inside here, because we actually want to start working on all of these. So for our setup, we have this, and now we want to start inserting these windows and doors inside our stud, and we want to make sure that they do not overlap. So this is where actually we're going to start doing a little bit of a different setup inside here. So let's make a little bit more room inside here. So right after the attribute transfer, and before we actually connect opposite points, let's actually put down a wrangle node. Connect it, like that. And now let's create our subnetwork. So since our setup for our points that we are going to copy our doors and windows are going to be a little bit more involved. So I'm just going to create a subnetwork right beside the wrangle and drag our group setup inside init like that, and let's go inside it. This is just going to give us more space for us to just worry about the point setup, because we're going to then bring out of this subnetwork. So let's start by converting lines. So let's put on null node. Let's call this like a base shape. Let's convert line. So let's start working on the windows. So I want to convert line, so we don't really need wrestling, so you can turn these off. Now let's blast it. And let's only get the bottom of these. So at p.y equals 0, like that. Now let's resample it. So this is where we can start adding some control. So make sure that it's resampled by edge, by polygon edge, and then the maximum segments. So what you can do is, so by default, I want to make sure that there is a possibility that there is one window per wall, like that. And then we can maybe add this to our, if our shed maybe is bigger, we can add more windows by every side. So let's actually add this to our HDA. So I'm going to open up my type properties for my HDA. And so for our Windows controls, let's actually add this segment to our Windows controls. Let's call this possible windows per wall. That's kind of big parameter name. Let's call this like that. Let me put this on the side like that. So now we have a possible. So why I call this a possible? Because we're actually going to randomly delete them. So that's good. Let's put down a polyframe. And for these normals, just like I did before, tangent normal like that, so that we get our normals like that. And now let's actually start by deleting the, so we do not want to make sure that there are no possible windows at the end and at the start of these polylines. So what I'll do is, just like with our HDA where we subtracted ends of it, we can actually go ahead on top of it. Let's go to our HDA that we actually created, and there is this code that actually subtracts from the polylines. Just copy it and let's reuse it right here like that. Create a spare parameter, delete the reference, and just one time let's delete it like that. So now we have subtracted it just like that, and this is very nice because now we can basically say how many windows you want per wall, something like this. So that's good. Now let's extract all the points like that. So that's good. And now let's put down our labs random selection. So this is going to basically just want to make sure that we can actually delete randomly these points. So let's say in this random selection, make sure that delete selected, something like this. We can control how many windows you want, and then we can also randomize it. Let's actually add these also to our HDA. So let's bring it up. Let's bring these something like this. Let's call this random delete ratio. Something like this. And random seed. Let's go to random delete seed. And let's bring these on, maybe on the back, something like this. one some maybe like this. So let's take a look at it. Then possible window is going to be on top of our random. Maybe something like this. Let me bring this on the side. So now we can randomly and how much you want to actually delete them. Something like this. Okay, that's good. So now we want to get the width of our windows. So even though we have created these, we want to actually make sure that they do not actually intersect with each other. So that's where actually we're going to start to get some values from our network. So you can do is create a quick mark inside this network, go on top of it and create another quick mark inside here. And then you can just jump between these two. And now let's get the width of our doors and windows inside this as an attribute for our points. So put down a float, attribute adjust, and let's get spare input reference from our doors and our windows. So what you can do is, if you're using my tools, you can just select our the window frame, select also P scale, go ahead and add spare input, and it should automatically create a parameter the spare input. But if you don't use it, you have to do it manually by add spare input and referencing the end of this parameter. And its value we want to say set always, and for the constant value we want to use a bounding box. So it's going to be -1, and that's going to be let's take a look on which axis actually it is. So we want to get this width, so that's going to be on x-axis. The x size, like that. So now we have our width of our doors, like that. So that's good. And we have put it on all of these points. And let's call this a width. Like that, let's take a look at it. So now we have width of our windows, that's good. Okay, we have gotten our width. Now let's actually, let's set our, actually let's put a wrangle node, and let's add the name of these, so let's add the string attribute. So s at name is going to be a window. So this is going to be a string attribute that's going to define on which points we copy our window and which on we copy our doors, like that. So that's good. And now let's start removing intersecting points. So that's going to be a little bit more involved. We have to put down a wrangle node, put it down, and let's start editing it. And before we start editing, let's actually create a little bit more our point, so that there's this possibility that they actually start to interfere with each other. So I'm going to just random ratio, put it at 0, like that. Okay, so let's go ahead and start writing this VEX code. Let's make sure that we are running over the details, so only one time. And let's start by creating an integer array. I'm going to call it toDelete. So this is an array where we're going to store all the points that we want to actually delete. So now let's put down a for loop. Let's call it pt, and it's going to be n points. So basically, you want to make sure that we are running over every point, and we're going to get the position of that point. So x vector pt, let's call it just the position. Let's call it pt position equals point attribute name going to position, and point number is going to our pt that we are running over. So what we're going to do is now is also get the float. Actually just copy it. So I want to get the width of that point. So let's call the width. So that's going to be a float, and that's our width attribute, and that's our pt. And now I want to get all the near points of that point. So now we have our basically our search radius, which is our width, and our pt position. Now let's call this. Let's create an integer array. It's called near PTs, and let's use a near points function. So 0, the PT is going to be our PT, and actually the PT is going to basically search. We can start searching from our point position, which is our PT position, and the max distance is our width, like that. One thing that you have to be aware of, that it's always going to find at least one point, and that point is going to be the PT position of our vector, because we are starting to search from every one of these point position, and the near point is always going to find this point. But we want to do, but we want to delete everything except for our initial search point position. So we want to make sure that we actually do anything if array has found more than one point. So let's put down if length of our near PTs is bigger than 1, then only then we want to proceed. And first of all, we want to get rid of our nearest point, which should have a index of 0 in our array. So what you can do is put down a pop function in array near PTs and index 0. So now we have gotten rid of our nearest point, which is this point. And let's say we have found these 2 points. We want to make sure that we delete them. Let's put down a for each loop. So let's call this int del PT, and the array is going to be near PTs. And then we want to make sure that this point isn't already in a delete array, because we don't want to add a duplicate. So if put down a find in array to delete del PT, basically if it hasn't found, it's going to be a negative index. So if it's smaller than 0, then we can append to the array to delete our delete PT. So right now you can see it's nothing is really going to happen. Let's actually, to see any results, let's go ahead and after our loop, let's put down another for each loop. Let's call it I'll just call it integer del PT, and the array is be to delete. We can do is remove point, and point number is going to be delete PT. So you see nothing is deleted because we are not basically, none of these are actually going to intersect. But let's go ahead to our HDI and let's actually increase our window size. You can see at some point it's actually everything is going to be deleted, and this is not exactly what we want to. So basically this is happening because of the basically if this point finds this one, so let's say we have this point finds this point. The thing is that the next point that we are searching, let's say this one, it also has found the opposite point also. That means it's also going to delete. Basically it means it's going to delete itself, each other. And this is actually not what we want to do. Is basically what to do is make sure that this point finds this point, marks it for deletion, and we have to make sure that we actually do not search the near points of this point because it's already marked for deletion. So what we can do is actually go ahead and put down an if statement right before we run all of this code. So if we find in a to delete array our PT, which is basically if we do not find it, it's smaller than 0, just copy these, and then we want to run this code. Paste inside here. We can indent something like this. So this should make sure that we only search the points that are search the near points of our points that are not already marked for deletion. So let's go back to our HDA and let's increase its size. So you can see we can basically make sure that there's always basically with any reasonable point with any reasonable points, you can see we have basically left some windows at all the sides. And now let's start working on our doors. So from this base shape, let's put down a blast node like that. Let's get all of our walls, all the other walls. something like this. So it's primitives like that. And now we have to decide on which axis we actually want to get our, basically on which axis we want to our doors to be. So this is going to be kind of, we have only one doors going to be, and we have to select it and blast every other wall. So put down a group. Let's call it wall door, something like this, and let's select it by normal. And I'm just going to select it that it's my wall is going to be on positive. Let's spread angle 0, direction X. Let's turn on our groups wall door. So my door wall is going to be this. So positive X-axis normal like that. And I want to delete everything except for the wall door. Actually, we do not even need this one because our normal is just one. So you can delete this blast. This. Now let's convert line. Convert line. So inside here, rest link we don't need. Let's put in the blast node. Let's delete everything but the bottom one. At p.y equals 0. Like that. So this is our basically the where we can put our door in. So what we can do is go ahead and resample it. Let's resample it to the resample by polygon edge. And maximum segments, let's put it to the 2. So this is going to basically want to just get one point. So this single point is going to be our door point. Let's put down a polyframe. And let's do the same thing. The normal as a tangent, like that. And take a look at it. We should have our normals like that. So it's good. And now let's blast everything except for the middle point. So since I have a simple set inside here, what you can do is put down a blast node and delete points. So we want to delete 0 and want to delete the last one, which is the function endpoints. Endpoints and a -1 like that, and delete deselect non-delete non-selected. This should basically give us a group 0 and 2 that we want to delete and leave us with a single point like that. We still have our normal, and let's actually go ahead and give us for our HDA to make sure that we can actually move our door location. So put down the wrangle node and put down as a point v at p plus equals. So we want to add to this position. And what we do is add to this position our normal positions. Basically, we want to just slide this point around our point normal. V plus equals v at n multiply by CHF offset. Let's call it door offset, something like this, and that should be it. Let's create this parameter. Let's move it so you can see we are now offsetting our single point along its normals. So this is going to, we definitely want to add this to our HDA. So open up our HDA and in our door controls, drag in the door offset like that. And let's make our range from maybe -1 to 1 like that. And yeah, over here we should have our offset like that. So let's put it on 0. So that's good. We have our offset controls. And now let's get the width of it. So just go ahead and copy this width setup. Inside here, our width is going to be instead of, and we just have to change our spare input. So instead of out window frame, just go ahead, copy this outdoor frame, paste inside here, and it should pick up our size of our doors. So that's good. And now I want to give it a string attribute, just like inside here. Just copy it, paste inside here. Instead of window, it's going to be door. So that's good. And all of this code that we make sure that there are no intersections. So what we can do is, let's say we later on going to expand this setup with multiple doors. What we can do is just go ahead and add also this code. So if this is right now, we have not set up with the multiple doors, so it's not really going to do anything. But in the future, to avoid any intersections, we can go ahead and put it inside here. So just to be sure. Now let's deal with intersections between doors and windows. So what we're going to do is make sure that our doors always stay wherever they are placed, and if they intersect with our windows, the windows are deleted. So for that, what we can do is actually, let's go ahead and create a visual representation of width of our doors. So what we can do, let's put on another wrangle node. Let me open this up inside editor. So what I'm going to do is actually go ahead and create a new primitives, a new polylines based on the width of our doors and windows. So let's do this by doing like this. So to the points. So let's create a vector. Let's call this position 1. Position 1 is going to be our current position v at p. Then we add equals v at n, which is basically the direction we just created, multiplied by our width, which is f at width, and divided by 2. So make sure this is in brackets, because we want to make sure that we are multiplying by half of the width, like that. So this is our position 1. And then we want to go ahead and create our position 2. Just copy this. Position 2. Position 2 is going to be basically the same, except we are going to subtract it. Subtract instead of add. And the width, instead of divided, we want to, it's a full width subtracted. And then we can go ahead and we add p equals position 1, like that. And then what we want to do is go ahead and add another point, int new pt equals add point. Add point is going to be 0, and then we want to give it the position where we want to add it is going to be position 2, like that. That's good. And then we want to go ahead and add primitive. So this is going to be 0. The type is going to be polyline. And then we want to give it the position point number that we want to connect. So we want to connect the current pt at pt_num, and the second one is going to be our new pt, like that. So if this is correctly done, you can see we have this setup, which basically we have created the width of our doors, our windows. So if you go ahead and change the width of our windows, like that, you can see we are adding it and subtracting it. And since we are also working with our code before that, we make sure that there are no intersections. Once we have created some of these points are intersecting, you can see they are actually deleting. So that's good. We now just have to give some of these points, some of these other points also its name. So first of all, we have added this new primitive. Let's set the new our new point that we just created the same name and the width of it, because right now you can see the name for our new created points are actually not existent. So set point attrib name, point number is going to be the new pt, the value is going to be, so the name is going to be window, and the mode we don't need. Then just copy it, and I want to also give it the width for our new point is going to be f at width, like that. So they should make sure that we have the same width and name for our points that we just created, like that. Let's call this set attributes for new points, something like this. So that's good. Inside here, we can just go ahead and copy this, paste inside here, and this is a representation of our door size. If you go ahead and size it appropriately. So yeah, okay, so that's good. Let's go ahead and now see the intersections that would actually happen. So put the intersection analysis. So this node is really cool. So just connect our doors inside one and our windows inside one and door second one. And you can see it's actually going to go ahead and create a new point. And what I want to do is I'm not going to touch anything except for this. I want to select the primitive number like that. And this is going to set the point number, basically the primitives that are actually intersecting inside here. So this array, the 0 is the primitive of the second input in this array. So this is 0, and this is in the first point is actually the primitives that are actually intersecting and I want to delete. So after this attribute, I can see that I want to delete primitive 3 and 2. And if you take a look at this, this would make sense because you can see this is our these are some our windows, and if you take a look at our door is basically overlapping these two windows, and these two window primitive numbers is 3, 2, and if you go to intersection analysis, you can see it's 3, 2 and 3, 2. So we want to delete these two primitives if they are intersecting. And if we, let's say, go ahead and change our size of our, let's say, doors. So let's say they are not intersecting, you can see we have nothing inside here, so there's nothing to intersect. But if there is, we want to make sure that they do not intersect with our doors and want to delete them. So that's good. Let's put down another wrangle node. So now we want to deal with the deletion of here of these and connect this intersection analysis as a second input for our wrangle. And now let me open this up. And now in the actual code, make sure that you have some intersections that are analyzed and make sure that you have this source prim group. I'm just going to copy because I'm going to use it in my Vex code. So inside this wrangle, let's write it out. So let's create an array of integer array del pts. So this is where we're going to look store all points we're going to delete. And now let's put down a for loop, and this is going to be endpoints. We want to run how many we have intersection points inside here. So that's going to be a pt instead of I, so it's a little bit more noticeable what it's exactly for. Let me bring this a little bit up. So now let's get all of the points of that. Let's get all of the intersection. Basically, get this group. So int. Let's call this inter array. It's going to be a point attribute. So it's going to be 1. Attribute name is going to be source prim, and point number is going to be pt, like that. Now I want to make sure that we actually go ahead and delete the 0 because basically we know that in this attribute the 0 is the this point. If we do not want to delete the 0 primitive from this one because this primitive has nothing to do with this primitive. So just go ahead and pop the last index of that array. So what you can do is pop inter array and select the last index, which you can just put down a -1. So we have now removed 0 from our arrays, and now let's just go for each. Let's call it inter pt, and then inter array. I want to if we haven't, basically we want to make sure that we do not add duplicates inside our delete pts. If find in our del pts inter pt, I wrote this wrong, inter PT. Basically, if it's smaller than 0, basically we haven't found it. We want to append it to our del PTs, inter PT, like that. So that's good. And this should be good enough setup for us to go ahead and then run, once we have completed that loop, put down a for each, del PT, del PTs, and then we just want to integer, then we just want to remove point. Actually, want to these are going to be this is going to be primitive, so I want to remove the primitive. Remove prim 0, primitive number is going to be del PT, and also 1. So I made also a bit of a mistake with the inter PT, because these are actually basically primitives, but that's fine, because it should at the end of it should still go ahead and delete them. If we go ahead and make our door size a little bit smaller, so let's go inside here and let's template this one. Let's actually look at this and template this one. So you can see once we have once our door size is a little bit bigger, basically starts to overlap our windows are deleted like that. So this is exactly what we want to make sure, that our doors do not intersect our windows. And now we can put this all together, but before that I actually forgot to actually put down, since I copied this visualization of our width from our windows to our doors, I didn't change the name of our basically our new point attribute. So I want to start inside the windows, I want to make sure it's a door. Yeah, so this should make sure that both of these names are door and window is correct. So now let's start to merge that all together. So for that, what we can do is start by merging both of these. So this has taken care of intersection, and these doors are always going to be there. So put down null node. Let's call it out windows, and inside here out doors. I'm just going to color them the same color I did for our frames. Position them. Now we can merge these together, but there is one problem. These are now polylines instead of points. That's going to basically convert them back to the points like these. So go ahead and put down extract centroid, and this, make sure that it's at the primitives. So this should basically get back our centroid points. So if you take a look at something like this and this, we should get the same points. But the problem is now that our attributes are gone. All of our name, width, and normal points are gone. That's because there is option for us to transfer attributes, but you can see there's nothing in it. That's because before our transform, before we actually transfer, we can transfer, but our attributes we want to transfer is actually a wrong time. So what you can do is attribute promote point attributes, and I want to promote them to the primitive attributes. We put down the attribute promote and put down the normal, name, and width, and we want to from point to the primitive promote it like that. Set here, and once we have extracted the centroid, we can transfer attributes, normal, name, and width, and this should basically be the same thing, but we have basically transformed them back to what we want. And let's put down two different outputs. So one output is going to be our copy to points, which is this, and the second one is going to be our basically up, and basically we need to mirror this setup. There are points up and down, and then we have to see which points are too close to our newly copied to points geometry. So copy this output node and put it indexed to 1. So the first one is going to be our two-side setup. So what we can do is put down a copy node, duplicate, and we just want to duplicate this geometry back on top of it. So get this base shape, select it, and get this pair input for this. I'm just going to use my tool, add pair input, and I just want to move it to the bounding box, -1 d y size, like that. And this should basically move my copy on top of this one geometry, like that. And this is going to be my output 0, so connect inside here. And now my output 2 is going to be only these points, and these points are actually the points that I'm going to copy my windows and my door and window frame. So I'm going to call it out. Let's call it this. Let's call it stud. Detection PTs. Something like this, and then out copy points, like that. Let's color them like that. Let's go outside, and now I think we have 2 points, and I look at that, they actually are colored. Oh, that's neat. I didn't know that. So let me color this red. Oh, you can see the outputs are actually also colored. Oh, that's kind of neat. I did not know that. Okay, let's keep it red, I guess. Then we can just connect this side here, and from this point I want to detect the intersection between the studs, and this one is going to go ahead and go to the copy to our windows and window and door frames. So let's do that. Let's write out this Vex code. So make sure that we actually run this only one time, because we're going to do the same thing with the defining array and populating the points that we want to delete, and then we're just going to run through the array and delete those points. So let's create integer array to delete, and now let's run a for loop, and the count is going to be n points. So we want to get the geometry 1. So basically connect the geometry inside here, because we want to get the position of our basically points that we're going to our windows and door points. So that's good. And now let's actually get the position. Let's start PT position, something like this. That's going to be point P, and let's actually call this PT, and PT, something like this. Now let's also get the V to it. Let's just go ahead and copy this. So that's going to be a float PT width. That's going to be attribute going to be width, something like this. Now what we're going to do is get the near point, near PTs. Let's get near points. So want to get the near points of this geometry, and the position is PT position, and PT width is going to be as how much you want to actually look for. So now let's run a for each. So that's going to be integer near PTs, and then want to just go ahead and append to the to delete basically if let's check if it's if find in array to delete the near PT is smaller than 0. Basically if this number is not already found inside there, we want to append it to delete near PT. So that's it for this. Now what I want to do is go ahead and actually delete all of these. So put down a for each. Let me drag this out. For each integer del PT to del array and remove point, and point number go to del pt, and that's it. So let's take a look at it. You can see that we are deleting a little bit too much points, and that's because our width is too much. Because if you think about it, let's say we are searching in with these points, and I want to make sure that they do not intersect. The radius of our right now, the radius that we are actually searching is the width of our window and door frames. That would mean that on both directions it goes the width of it of doors and frames. But what I want to actually do is divide it by 2. So just inside here, pt width, just go ahead and divide it by 2, and this should make sure that we are now correctly deleting these points. We are not deleting more stats that we need. So let's take a look at that a little bit. So at the end of it, we should have these cutouts ready for our studs, for our frames, for our walls, and for our doors and windows. So let's go ahead and get our second connector. Before that, let's go to our out inside here. Let's go ahead and merge these together. So what I want to do is now actually let's delete these bevels. We don't need them, but we need a wrangle node. Put down wrangle. Put down a primitive attribute. So let's go s at name, and this is going to be window. So this is how we're going to copy the points, match the piece, and then just go ahead and copy this right before the out. Inside the window, there's going to be a door. It's name and name, like that. Make sure that these are primitives, otherwise it won't work. And yeah, now we have merged it. Let's go ahead and create our cutouts. So let's put out the null node. Let's call copy copy PTs. That's fine. Let's go ahead, copy 2 points. Let's put it maybe so we can move all of these on top of it. Maybe somewhere here. Let's create it also inside the frame, like that. Let's also color it. And now let's make these points to the required points to copy to, like that. And the geometry is going to be this merge node. Just inside here, make sure that piece attributes name, like that. And one thing we have to do is now actually we did I did a wrong thing, because our output is these lines. So let's go back inside and let's fix it. So inside my output 1 is actually these points. What I do is instead of I want to make these points my outputs. Basically, before we multiplied, before we create our basically our intersections with studs, we want to make it these points, because we only need these points to copy our frames to. So that's where we have this problem. If we go ahead, copy. So this looks not correct. We need to actually transform our frame. So put on translate, transform, and just rotate 90 degrees by on the y-axis, and make sure that all of your these two should be aligned on top of it on the 0 axis. So they should be aligned perfectly, because this is where we're actually going to copy to. And once we have transformed it, you can see that our copy to points is actually going to go ahead and align it. So this is this is because of the normals of our point and the alignment of our geometry. So what we're going to do is by transforming, we have aligned our z-axis of our geometry be aligned with the normals of our points that we are copying to, and that means that now these are actually aligned like that. Now what we can do is go ahead and merge these together. So let's merge our whole geometry with our copied geometry, put it together like that. So we need a little bit of a fix up inside here, but if you go ahead and change some of these values, there's a little bit too many studs. This should, for most of the part, make sure that we do not intersect each other with the geometry, and our studs should get away from the window frames like that. So yeah, and now let's fix these overlaps on top of it. The overlap inside here stems from the fact that we change our line origin where we get our length and length of our lines. What we can do is, so you can see that we got the y size of our length, but the problem is that this is basically the very top of our frame, which means that we actually have to make sure that our line is actually smaller than the thickness of our base of our floor of our stud board. So just copy the thickness reference and go inside the line, and instead of length, basically we get the bounding boxes y and subtract the thickness of it like that. Then we can just copy it, go back to line 2 and paste inside also here. Now it should make sure that we do not have any overlap like that. So that's good. We have fixed the overlap. And this will conclude the part 2 of this tutorial series.